Hey guys, welcome to lesson 113. Today we're going to be talking about key points on a graph, and this time we are going to include domain and range. All right, so our goals for today are to understand how to graph a function. We talked a little bit about that yesterday where I showed you how to use your calculator and the table feature to create that graph. We're going to identify key points on the graph using appropriate notation again. We want to understand what domain and range represents and then be able to identify domain and range of a function given a graph. All right, so in our first example here, we have our function f of x equals the square root of x plus 4 minus 3. And I've already got that graphed here. I used Desmos to graph this thing. One thing I do want to add to the graph that I couldn't get on Desmos was this arrow on the end, just indicating that this function keeps going off to the right forever and ever and ever. It also keeps going up forever and ever and ever, right? So it goes off to the right and up, and it never stops doing that. Okay. They also didn't plot a point here, so I'm just going to add a nice point here at the end of that function. So this is where this particular function stops. All right. So some of the key points that we learned about yesterday, we talked about x-intercepts. So this would be where our function crosses the x-axis. So our x-axis is actually located right here. It is this line that runs horizontally through the graph. Our y-axis is located right here. It is this vertical line that runs through our graph. Okay, so when we want the x-intercept, we've got to figure out where does the graph hit that x-axis, and it does so right here at 5. But we don't want to write just 5. We want to make sure that we write the location of this point right here. Okay, and a location is a coordinate. So I'm going to say 5, comma 0. All right, so for a y-intercept, we would look for where our function crosses the y-axis. Okay, that's going to happen right here. And again, we want a location, so I have to write an ordered pair for a coordinate. All right, and this one happens at 0, -1. Okay, so now we have our y-intercept. Yesterday we talked about the minimum. Remember, the minimum is the lowest point on the graph. And I just want to draw a quick picture here because this graph doesn't really let us see it, but I also like to describe minimums as valley bottoms. So if we had a function that kind of looked like this, for instance, we would have a minimum located here because this is at the bottom of a valley, and we would also have a maximum located here because it's at the top of a hill. All right, so it's just a different way of visualizing what a minimum or a maximum looks like. It's the high and the low points of our function. Okay, so what we're looking for in our graph is a minimum. We're looking for the lowest point on the graph, and that's going to happen here. This is as low as the graph goes. So that occurs at -4, and then 1, 2, 3. So -4, -3. Right? And then the maximum is going to be the high point of the graph. And remember, we talked about this graph. It keeps going off to the right and it keeps going up forever and ever and ever. So there is never going to be a highest point for this graph. Okay, so the maximum is none. There is no maximum for this graph. Okay. So now we're going to talk about something called domain and range. All right. So what the domain describes are the x values. Okay, so we talk about what allowable x values can we put into this function. And the easy way to figure that out, what x values can this function use, is by looking at the graph and seeing how far to the left it goes and how far to the right it goes. Because the x-axis runs left to right, we can look at where our function stops as it goes to the left and where it stops as it goes to the right. And that'll tell us all of the x values that this particular function can handle. All right, so I always like to think of domain as left and right on the graph. All right, so if I'm looking at this curve that's generated by our function, it stops right here. This is as far left as it will go. Right? It will not go any further left than right here. And you'll notice that that particular value on the x-axis is -4. Okay, so if I'm going to write my domain in interval notation, I'm going to start by writing its left bound. All right, so it's bounded on the left at -4. And then I need to figure out its right bound. So you might remember earlier I talked about this function. It keeps going off to the right forever and ever and ever. It never stops. Okay, so there is no right bound, so we would say this function goes off to positive infinity. All right, so we can have any x value starting at negative 4 and ending at infinity, right? In fact, it never ends. All right, so to complete this interval, what we're going to do is we're going to put a square bracket on the negative 4. And what that square bracket tells me is that we can actually get to and include the negative 4. So when I go up here on my graph, I can actually trace my graph to the negative 4 here and touch it. Okay? But for the infinity, we're going to put a curved bracket. Okay, so this is a curved bracket, and I can draw that a little bit better. All right, so you put a curved bracket there, meaning we can't actually get to this number, right? Infinity is not a number that we can get to, so we have to put a curved bracket on there indicating to the reader that we cannot get to positive infinity. We can get to the negative 4, but not to the positive infinity. All right. Another way to write this is with something called inequality notation, and this is where we use inequality symbols to describe what x can be. And I like to think of it as an in-between kind of thing, right? So x is in between two numbers, right? It can be any value in between these two other values. And I can grab those right from my interval notation. Okay, so if I think about it, I can put negative 4 right here and say that x has to be greater than negative 4, right? I can't be anything less because the function stops here. So it's got to be a number that's greater than negative 4, but also less than positive infinity. All right, so think about x goes in the middle, and then my left bound and my right bound go on the outsides of this inequality. And then I got to think about my equal to symbols. Since we can actually get to the negative 4, I need to put in equal to bar underneath that inequality. But since we'll never get to the infinity, I'm not going to put that bar underneath this one. Okay? So you'll have to make sure you read the directions on MyOpenMath. They might ask for interval notation, they might ask for inequality notation, and you need to be able to write both of these. Okay? So let's try range. So range described all of our, domain described all of our x values, which we determined to be how far to the left and how far to the right on the graph we could go. Well, range describes all of the y values. Right? What y values can our function give us? And we can see that easily by looking at our graph and asking how high and how low can we go? Okay, so this is high and low, right? Up and down. Right? So when we talk about interval notation for this one, I'm going to start by writing my lower bound, right? So how low does the function go? And we're looking at the y-axis here. Okay, so this is the lowest point, and it'll go down to 1, 2, 3. So it gets down to negative 3. So I'm going to start my interval at negative 3. And then I got to ask myself, how high will this function eventually go? And remember, it keeps going off to the right, and it keeps going up forever and ever and ever. So it's going to go from negative 3 to positive infinity. We can actually get to the negative 3, so I'm going to put a square bracket on the negative 3, and I'm going to put a curved bracket on the infinity since we'll never get to the infinity. And I can write this in inequality notation, but instead of using an x this time, we're going to use a y because range talks about the allowable y values. So I'm going to set it up just like I did over here, but I'm going to use a y. I'm going to put my inequality symbols there. I'm going to put my lower bound on the left and my upper bound on the right. And I'm going to make sure I put an equal to bar under this one because we can get to the negative 3. Okay? So that's how we determine domain and range. All right, let's try it again. And this time we'll do it for a parabola. And I've already graphed our parabola here, so we'll start with the same thing. We're going to start with our basic key points here: x-intercepts, y-intercepts, minimum and maximum. Okay, so x-intercepts, I see 2 of them right here on the x-axis. One is at 1, 0. I have a second x-intercept here, so that's 1, 2, 3. So this one will be at 3, 0. And remember, you can find those in your table on your calculator as well. Okay, y-intercepts, where does the parabola cross the y-axis? It crosses right here. And that's going to be at 1, 2, 3, so that's negative 3. So this one's going to be at 0, comma, negative 3. Okay? Don't forget to put your arrows on the end of this parabola because it does keep going down forever. That becomes important when you start talking about minimums and maximums, right? So if a minimum represents the lowest point on a graph, and I have a graph that never stops going down, well, we're never going to have a minimum, so this is none. All right? Now maximum is the highest point. Remember I was talking about those hilltops earlier, and I see a hilltop right here. So this is a vertex, or in this particular case for this graph, this is a maximum. Okay? So my maximum occurs at 2, 1. Right, so I'm going to say 2, comma 1. All right. And now we're going to start talking about our domain and range, right? Because now we have to be able to identify those things. Remember, domain is left to right, so we're going to start with interval notation. Now remember, our parabola on the left-hand side here keeps going down, and it also keeps creeping over to the left. It never stops doing that. So it goes down and to the left forever and ever and ever. Okay, so it's going to go off to the left all the way to negative infinity. Okay, so when we head to the left forever and ever, that's negative infinity. If I look at the right side of my parabola, if I try and go as far to the right as I possibly can, this parabola goes down and to the right forever and ever and ever. So the right bound is going to be positive infinity. So our parabola goes from negative infinity to positive infinity, and since I can't get to either of those numbers, I'm going to put a curved bracket on both of those. Okay. So for inequality notation, if I wanted to write this with an inequality notation, I'm describing x values, right? So I'm going to put my x there, I'm going to put my two inequality symbols, and then I put my left and my right bound on either side, right? So left bound over here, that's negative infinity. Right bound over here, that's positive infinity. And since I can't get to either one of those numbers, I don't need any equal to bars. All right, so remember range is up and down, right? High and low. So how low does this function go? And we talked about this already, right? So how low does it go here on the y-scale? This thing goes down forever and ever and ever, right? So when we go down forever and ever and ever, that's negative infinity, comma, and then we have to ask ourselves, how high does this thing go? Okay, so this parabola gets up to right here. This is the highest point that it'll achieve, and that happens at 1, right? So on the y-scale, it gets as high as 1. So we can't get to negative infinity, so curved bracket. We can get to the positive 1, so square bracket. So there's our interval notation describing the range. And then our inequality notation, right? We're describing y values. So I'm going to make sure I say y. I'm going to put my inequality symbols on either side. Left bound was, lower bound was negative infinity, and our upper bound was 1. I can't get to this one, but I can get to this one, so I need an equal to bar over here. All right, guys. That's it for today's lesson. Give the problems a try. If you have any questions about domain and range, hop back over to the Zoom meeting and ask away. Have a great day.